Hello children, this is Ashani from Cheenta.com. In this video, we will learn a lot about combinatorics. This problem is useful for mathematical Olympiads such as IUQM, American Math Competition, as well as ISI-CMI entrances. In the middle of this video, I'll also give you a challenge problem. If you can solve it, put in the comment section. We usually award the best commenter every month. Let's get started. So this problem says that there are a set of numbers x1 to x50. So x1, x2 up to x50. Let's call this set capital A. And there is another set of numbers y1, y2 up to y20. So this is, let me write it in red, y20. So there are 20 numbers in the set B and 50 numbers in the set A. 50 and 20. And we want to construct functions from A to B, the set A to set B. These functions need to be onto. Onto means for every element in B, there is at least one element of A coming to B. There is at least one element of A coming to B. So you can think of this function as a collection of arrows from set A to set B like this. And for every element in B, at least one arrow is coming to it. There could be more than one arrow coming to it. So f is onto, and there is one more condition. F of x1 is less than equal to f of x2 is less than equal to f of x50. Like dot dot dot. So this is a monotonically increasing function in that sense. If you think about x1, x2 up to x50 as numbers increasing from 1 to 50 or something like that, you don't have to. But the output values are in an increasing order. How many functions like that are there? Okay, so without loss of generality, we can assume that these are in the increasing order. We don't have to assume this, but it will be easier for us to explain the problem if we do. If it is not in that order, just rearrange it and make it in a monotonically increasing order. Therefore, then it will be easy for you to understand what's happening. So let's use the most essential problem-solving strategy that we talk about in our Math Olympiad programs and ISI-CMI entrance programs, is that construct an example. This is a magical strategy, friends. If you construct an example, immediately some inner patterns will come in front of you and you will learn more about the problem. So I will construct one such function. I have assumed that y1, y2 up to y20 are in an increasing order. So I think we can do it like this. x1 goes to y1, x2 goes to y1, like this, up to, let's say, x31 goes to y1, and then x32 onward, it will go to y2, x33 goes to y3, up to x50 goes to y20. So the last 19 elements will go to y2 to y20, and first 31 elements goes to y1. You see what happened, right? I constructed a function that matches our description. fx1 is less than equal to fx2 up to fx50. And I've constructed an onto function, that is every element has at least one pre-image. y1 actually has 31 pre-images. 31 pre-images. But the remaining numbers, they have exactly one pre-image, right? This is one such function. So let us analyze this example. It basically tells you that how many elements goes to y1. So let's write that as a1. A1 is the number of xi's going to y1? How many x values are going to y1? That's what a1 is. How many, so in this case it is 31. How many xi's goes to y2? Number of xi's going to y2. It's a map, right? Function, it's a map. So it's 1, a2 is 1, because only x32 is going to y2. So all the remaining are 1. So a3 is equal to 1, like this. You have a20 is equal to 1. So all of these numbers should add up to 50 because there are 50 elements in the domain, x1 up to x50. So a1 plus a2 up to a20 should add up to 50. And each of them is at least 1. So I hope you understand that every time we have a solution of this one, a positive integer solution of this one, we actually have a function that matches our description. You can try this as an example. Here is a challenge problem. That what function is it? If a1 is 1, a2 is 2, a3 is 2, and all the remaining ones, a3, a4 to a19, they are all 1. So first challenge is what should be a20? Try to put it in the comment section. And secondly, a20, what it should be. And secondly, can you explicitly describe the function that this solution represents? Okay, so if you can, put it in the comment section, and I hope you will be able to see what's going on. How many positive integer solutions are there of this equation? This is a well-known problem in the field of bijection principles, non-negative integer solutions of an equation. So what we do is, since we want all of them to be positive, at least 1, so what we do is we actually throw in 1 to each of them. So we initialize each of them by 1. So now we have a1 prime plus a2 prime up to a20 prime equals to 30, because 20 of these are used, right? 1 has been inserted in each of them. So 20 is used, 30 is remaining. So now these can be 0. So now how many solutions are there? This is a very well-known problem. I have discussed it many times in the Math Olympiad programs as well as in this particular channel. You can check that out. This is 30 plus 19, choose 19, or 49, choose 19. It's a very important result in combinatorics. So I hope you learned something from this video. If you did, then put a comment in the comment section. Thank you for joining us today. And you can also check the link in the description for the courses that we have on mathematics, physics, and computer science. I think you will like them. Thank you. Take care. Bye.